I hope everyone's having a great GTC. We appreciate you being here and having lunch with us and taking time to learn about how Core42 thinks about building the next generation of sovereign AI infrastructure. And we're joined by Chris here from VAST Data. He is VP of AI Solutions. And Raghu Chakravarthi, what is your title? I'm not sure
I am the EVP for software engineering and GM for the US.
Very good.
Yes.
All right. Well, I think a great place to start, and I don't see with a technical crowd here a lot of reason to go too high level. Let's just dive in here. Talk about what Core42 does on the infrastructure side in particular, and loop in also what it means to build what you do for the world that we're going to be living in.
I know. So our mission, like Core42, it's a UAE-based company. It's funded by some of the largest sovereign wealth funds. Our mission is to enable AI for every level of human engagement and human advancement. It's an audacious goal. It's a very simple goal, but audacious. And for me, and the Core42, it's about building this notion of an AI intelligence grid. So it spans the world. It enables AI infrastructure for any kind of industry. Mostly we focus on government and the enterprises, but we want to bring AI to the entire world in a connected way, right? For both model training and model inferencing. And our company specifically has a very big focus on this notion of what we call the global south, all right? To enable intelligence for global south. And can you imagine, 40% of Africa still doesn't have running water or electricity. Imagine if they are given that power and also given the information that they have, it'll basically advance the entire human generation. So that's what we believe in. So we're bringing AI to the world.
Okay. Let's talk about building the infrastructure needed to make that happen. And Chris, I know you have some insight about how VAST fits into that. That's pretty critical here.
Yeah, we've been a partner of Core42 for quite a while now.
Yep.
We're looking forward to working with them on the build-outs that are currently being planned. I think the important part here of what Core42 is leading is truly what was considered a sovereign cloud architecture. And the core of sovereign cloud regulatory schemes is data management. And this is where I think our two companies come together so well, is that the challenges of managing data provenance, data security, data archiving, and then of course the more mundane things of being able to present the right data to the right model to the right time is really the foundation of our relationship. As Raghu was saying, they're looking at a very, very distributed world and a very connected world. So the movement and management of data becomes incredibly important. And that's really the work we're doing together, is how do we use the VAST data platform and all of its capabilities to support what is a very, very enabled but complex system of data movement and management across the world that Core42 wants to build.
Mm-hmm. Well, let's dive into some of the nuts and bolts and challenges of building out this kind of infrastructure. I mean, what are the implementation requirements? What are the infrastructure requirements for this?
Before we get into that, the main thing is sovereignty, right? So we talked about sovereignty. So funny story. So I'm in a WhatsApp group with all my college buddies. So a week ago, and these guys are chatters, there's hundreds of messages in there. So what I did is I exported the entire WhatsApp chat, and then I sent it to ChatGPT to summarize so I know what the hell's going on. So then cheating. So it summarized it for me, and then I posted that back in the chat. And I got hate mails. I said, how could you? This is the only channel we have where we could have a private conversation and it stays within us. How could you give it to ChatGPT and then have them train on it? Sovereignty. Okay, so this is a fundamental. This is with my friends, right? Imagine what governments and military institutions across the world are thinking about in terms of sovereignty. Sovereignty is a key component, right? We need sovereignty. We need to enable sovereignty because privacy and security is paramount. So that is one of the fundamental principles that we have in us building our infrastructure. Okay, so we enable sovereignty, for governments, for military, for private institutions, for enterprises, both in the public cloud as well as in the private cloud. Also, UAE as a country is enabling AI for the rest of the world. So what that means is we are signing, UAE as a country is signing government-to-government deals with like nations across the world, India, Kenya, Kazakhstan, Turkey, and so on and so forth. And we are enabling AI in these countries. We're building infrastructure. In the meantime, they need data. So they have very secure private data that they want to analyze and produce some intelligence on to enable their citizens, right, like for services. And they are giving us data. This data is going to be resident in UAE, and we are going to provide intelligence on it. This is what we call virtual sovereign services, right? Like so, our infrastructure is built on both the public cloud as well as private cloud with sovereign controls in place. What I mean by that is a set of sovereign policies to enable security, to enable sovereignty, and a set of security policies that enable proper encryption, proper compute structure and everything, and bringing it all together in what we call secure landing zones, both in the public cloud and the private cloud that we built. So that level of infrastructure is there. So that is the enablement. Great. Now you have to work with these guys called the regulators. So the regulators enable or enforce what they perceive as policies for that nation. So we work with nations' regulators to enable these policies to be monitored and audited, and we connect our infrastructure back to the regulators' infrastructure, whether it's a national SOC or whether it's a national PKI infrastructure. We connect back to them so they have the visibility to enforce and certify these infrastructures to be sovereign. So it's pretty exhaustive. It's not easy, but with a set of policies and landing zones and the connections we have with the regulators, we enable all of this to happen.
Understood. Then that makes me retune my question a little bit. I said, because I just wanted to dive into the technical details, and it's good that you outlined all that first so that we have great context. But now I'm wondering, first of all, is this kind of an unprecedented data management and security, privacy, multi-tenancy problem that we have reference for in enterprise and from different places? How unique and new is this problem, and how difficult was it to start even thinking about it?
I think the problem of doing true sovereign AI is a new problem. It's presented a set of challenges that the typical enterprise just doesn't have.
Right.
Enterprise has kind of dealt with privacy by physical separation, right? So I've got my stuff in my data center, I've got my stuff in the hyperscaler, I may have some stuff at a colo, and government does the same, right? Government needs a cloud, they maybe have a private instance of that and the rest of it. So we've kind of used that. The problem for that is in AI is about data movement fundamentally. AI is the fuel of AI is data availability, and so if you truly silo it and balkanize it across different physical platforms, the value of it decreases. There's no Metcalfe's law that a value of a network increases with the node. Well, AI, someone's got to write when we do Ragu's law is going to be the value of AI increases.
You heard it here.
Increases with the number of petabytes available to the model, right? I mean that is what we need to have both parts of this. Right. We need the ability to control and to regulate and to audit data. At the same time, we have to make sure data is always available at the right place at the right time for the right user. And this is the challenge that's really, really new. And this is quite honestly why I think the relationship between Core42 and VAST is so important for the success of this. Is traditional kind of storage systems and data, I'm going to copy a file from A to B, that just doesn't work.
Yeah.
You need to have extended metadata. You need to have a bunch of the ability to do functions on the actual storage. You've got to have that data look like a table and be queryable. So to fulfill all these different requirements and constituents around the data, because that's what it is. We're so used to having data just be ours, and now data is really a community property.
Right.
There's a lot of people, a lot of constituencies who have a say about data now. which is really the system, the solving those people's rights on the data and rights to oversee the data is really what sovereign cloud is ultimately
No,
about.
it's important. I mean, like, so VAST provides like three critical components for us. One is the compute nodes, the separation, the disaggregation is very important to us, right? Like compute and storage separation. The second thing is on the compute side, we leverage the data warehouse and the vector store that you guys have built so that now, when I have a grid, right? Like I have locations, multiple islands of compute, multiple locations of these islands, and multiple continents of these islands. Now, how do I transport this data in a sovereign, secure manner without having to basically take it out of the system? So VAST enables that. The third thing is all about enabling sovereignty through our encryption mechanisms. So their metadata layer is very important because that's where I set the security, who can see what data, right, in the system. And when I transport this, that security is information and the metadata is transferred along with the data. So now I don't need to enforce this in multiple locations, so which is really helpful, right? So those three components are like very critical when you're actually managing data in a distributed manner. And it is becoming a distributed problem with inferencing, by the way, all right? Like,
Yes.
so as Jensen talked about, inferencing is the way to go going forward. Distribution of data, which is the most important thing, and how you secure that data and figure out who has access to what is an important factor.
Yeah. I remember looking back years ago and watching NVIDIA go from GPUs for HPC, for supercomputers, and then AI came along. It's like, wow, you were in the right place at the right time.
Yes.
And I listened to you talk about sovereign AI cloud building
Right.
and all the requirements, and I think, wow, VAST was there at the right time.
Correct.
For this trend towards inference and sovereign clouds. It's like you're at the bleeding edge of where things are going to go. So with that in mind, can you talk about the evolution of the platform overall and how it represents broader workloads beyond this? Because I think the Core42 case highlights all the capabilities in the most succinct possible way.
Yeah, I think that, and I think Raghu started down this path, right? Brendan and the rest of the founding team at VAST did an amazing thing, and they basically took on a really hard challenge, which was to revision how you actually manage data, and not to just create another, data storage product, but they recognized the Google file system approach, was just not going to get the world to where it needed to do. It needed to be able to do the functions that we were just discussing. So the first thing is the idea of being able to disaggregate between the compute, where the software that manages all this is, and where the state is. And then once you do that, and you're able to actually manipulate the data on its path into the QLC storage, you start to do all kinds of great things. You can add a massive metadata field that allows you to start to tag it in ways you couldn't before. So as that data moves around, it moves its history with it. It's like a passport for data. Is that I can now see what that data block is about. As the company has grown, we've started to actually you start to think, okay, first now it's multi-protocol. Really important with an architecture like what Core42 is building, because they can't afford to have multiple systems. I can't jump from, here's my object system to my file system to my block system. Mm-hmm. That will never work at scale. You have to be able to ingest in one and push out in the other. So just that next piece was really important. The next piece is just scale. The fact that you have an architecture that can scale not only within a single cluster in a single physical location massively, but then that cluster can essentially be a giant virtual cluster that shares a namespace, and that namespace can be shared globally. So from an end user perspective, they don't really care where the data is. And again, that protects sovereignty. If I'm an end user and I'm going to get access to data, and I don't need it in my physical domain to do that, that's a huge and powerful tool for being able to maintain sovereignty. We solve those problems. The next problem is what work can I do on the data while it's on the data platform itself, right? Now I'm starting to give compute resources back to where they should be. Compute resources in AI, everybody knows, is expensive, really expensive. So if I can start to move compute resources or compute functions onto the storage platform, that becomes really valuable, especially in inference. If I can do, use Kafka endpoints out at the end of an inference, point, now I'm doing very, very powerful things with the data without having to backhaul it all the time, without having a long return time set, so we can get under 200 milliseconds so people don't start hitting return all the time and looking for what's going on. So the platform has evolved over a number of years with all these functions and really unusual things to find in a data platform to enable exactly what the folks at Core42 have been building.
No, it's important. If you take one thing away from today, it'll be this notion of a unified architecture. Okay, so on the storage side, typically, what has it been? I need a fast object store. If you look at the NPC spec from NVIDIA, they say, oh, you need a fast object store, you need a fast block store, and you need like a fast scratch, and you need a fast staging. But if you have this complexity, imagine moving data around between all of these systems.
Possible.
And that there in itself, you're losing a lot of time, right? So a unified architecture is a better approach, in my opinion, and that's going to be really effective when it comes to inferencing. So multimodality is what everybody's going towards, right? Like every model is going to be multimodal. It's got voice, it's got objects, it's got images, it's got video and text. When you have all of this, your storage cannot be separate. Like it needs to be together to process the kind of inferencing latency and the expectations the customers have.
And it's at that point, it's not even really storage anymore, is it? Whatever the word is, it is what we used to know as racks of flash or even tape off in the corner, or spinning disk. None of that is the old world of things. I want to ask you something based on that distributed computing point that you made earlier. If you were to build out what you're doing now using pre-VAST technology, imagine all the different pieces you'd have to have, all the software glue you'd need to like make all of that work together, and would it even be possible to build an inference-focused sovereign AI cloud without this new way of thinking about data and being able to access it and use it versus
it is possible. I'm glad my CFO's not here. I'd be asking for a bunch of CapEx, but the complexity, the more moving parts, the more complexity, I think about the customer all the time, right? Like, so what does the customer want? What does the customer need? And they want low latency for inferencing and high bandwidth for training, right? Like, so that's all they want so that they can do their work. But if I have to move data around between all of these systems, yes, I need to have a object store, all of these stores. It's just going to be too slow. And I need to have an army of people in the back maintaining and monitoring and managing all these systems.
And multiple points of failure.
Exactly.
Right.
Exactly.
And security violations. It's almost impossible to get a zero trust certification on data movement that requires people to intervene with the data constantly.
Exactly. Exactly.
Right. Yeah, definitely.
And I think the word storage is one of the really antiquated tells of this whole thing. AI is about data movement. AI does not do storage of data, really. Is once data is in that workflow, it's going to keep moving. So that's why we don't talk about storage at VAST. We talk about data management and data movement and data platforms, because that's actually what we all have to build. Is we have to understand that this is no longer a traditional enterprise application processes some data and then it goes to rest as fast as humanly possible, eventually getting off to Glacier or tape or something. That is not AI. This is all about that data movement, that data access, and without that, the system doesn't work. So we're creating something that's completely new from a use case for all the data we've collected for all time.
And you'd never be able to scale. Well, you can scale it. You can keep adding flash and then companion compute what a messy process to scale. So how are you thinking about scalability going forward? Not just hardware scalability and security scalability, but how does that look and work, and what's possible now?
So we think about it in two dimensions. So I talked about how UAE is signing government-to-government deals, and now we are enabling nations, right? Like other nations for AI, right? So the first thing is, how do we now have a infrastructure in the UAE or in our intelligence grid to enable the other countries over the next 5 years as we build them out. How do we enable them? So for that, we need to scale both in the public cloud as well as in the private cloud, because not everything needs to be in a private cloud. There needs to be some workload. So for example, we're going to move all of our genomics. By the way, in UAE, we have scanned 70 million citizens and residents' genomes. Okay, we've sequenced all of that, 70 million of them. And now we are building a large language model to help solve problems. As the patient walks in, we can now help predict and diagnose their condition and give them a proper, even both for the doctor as well as for the patient. That data, we are moving from a private cloud to Azure public cloud that is secured and sovereign in a sovereign way through our systems and enable processing or inferencing over there. All right. So this is a very valid use case, not just for UAE, but for every other nation. So we think about scale in two ways. One is, how do we take tier one, which is super sensitive data, and build a private cloud and create a box and be able to replicate that across multiple nations. So this is compute, storage, and networking all together. And then enable not sensitive workloads to be run in the public cloud with sovereign and secure controls enabled. And we do all of that at multiple scales. So it needs both public and private, and enable, have this notion of AI in a box that can be now replicated across multiple locations and targets.
I just had an image in my head of how we used to have phones in our houses, old school landlines.
Yes.
And then that just made me think of cell towers, where compute is this mutable thing. It's sort of everywhere as long as you have the governance and and all the things in place. I don't want to run out of time, and I know that there are probably some questions out there. Does anybody want to kick that off? Lauren's got the microphone back there.
Everybody's shy today.
It's been fun.
They're full from lunch.
How's lunch? Hopefully, good lunch. All right.
Okay. No question. There we go.
Hello. I have a question on how do you want to expand in the US, and how do you want to approach your clients in the US with VAST?
So a couple things.
I can talk.
You want to say something? You say
I can talk about how we are expanding, right? So we have a data center, and so right now we operate about 35 exaflops of capacity in the US.
Wow.
And that is with our investment in Cerebras, where VAST is powering our storage, right? And that's primarily a training model. So we have trained, again, we enable nations, right? So we have trained the first Arabic language LLM called JACE, which is a dual language LLM on this platform. We have also trained the first Hindi language LLM for the Indian government called Nanda in this platform. But we see the trend towards inferencing. So far, there is only one company that's made money off of training, which is the host of this region. But as we go more towards inferencing, that's where the rubber hits the road, and that's where the value to enterprises and end users and customers are coming through. So we have built a capacity in Buffalo and New York, where we have 70 to 100 megawatts of capacity built out. And that's where we are transforming and implementing a lot of the inferencing capability. And our strategy with VAST is to go across two dimensions. One is the large language model trainers are going towards inferencing, and we are working with them to build out the inferencing capability because they are more focused on training. And the second thing is go direct to market with partners like VAST, so that we can bring inferencing across a diverse set of silicon, diverse set of models, and a diverse set of locations, both public and private, to the masses.
Yeah, what I would add to that is our go-to-market around AI and how we help our end enterprise customers, government customers, is pretty straightforward. We recognize that there's physical limits to what most enterprise data centers can do around AI themselves. So you have to think about how a customer is going to consume. And the truth is that the vast majority of customers, even Fortune 100 type of customers in the world today, cannot build this themselves and put it in their legacy data center and operate it. They need to get services from providers like Core42. So our entire go-to-market here, from a VAST perspective, is to pick and partner with the best operators and innovators in the services market around AI, people like Core42. And then as we work with other customers, it's not that we want to take them necessarily to put VAST into their own data center. There's purposes for that to modernize legacy infrastructure. But when it comes to the AI functions of model training or inference, we want them to team up. And so we're driving our customers to work with our select partners here to be able to consume VAST in the service offerings that are bundled together with all the value add that a Core42 brings to the party.
Yeah. Yeah, thanks for that question. How many exabytes? What?
Exaflops, yeah. So we
Exaflops.
yeah.
Oh, exaflops.
So at the end of the day-
So compute, not capacity. we're
compute.
talking
Like
about.
we
Okay,
think in
right.
terms of two dimensions. One is the power and the
I got it.
compute
Okay,
capacity. So at the end of the day, we'll be operating close to 5 gigawatts. This can power the entire world, but 5 gigawatts of capacity, which would turn out to be hundreds of thousands of exaflops. So but that's what nations need, when we
Yes.
build nations.
I've had many times this week where I'm just like, that's one of them. Do we have any more questions this week for this panel? Yeah.
You mentioned your focus is on global south, but now it's all US, so you have such big capacity in other global south.
Very, very good question. Unfortunately, the global south doesn't have the capacity for power and water to build this out. So what we are doing is the whole virtual sovereign service. So we are building capacity for the global south in the places where there is capacity. And in the meantime, we are building data centers. We are building power plants. We are building subsea cabling for these nations to enable them, all right? But that's going to take time, 5 years. But those governments like Kenya, like South Africa, like Turkey and Egypt, they're coming to us and saying, I need intelligence right now. So with virtual sovereign services, we are transferring data in a secure manner from their locations to our data centers, processing the information and giving them data back, right? And eventually, as we build out over the next 5 to 10 years, we'll build out the infrastructure there from power, from data center capacity, from subsea cabling and networking, and then enable it for those countries.
And that's really what your pod strategy is that landing zone within.
Exactly.
Exactly. So
Exactly. Yeah, and that's where.
Latency is not a big concern right now for you.
No, we are building, so we are also into subsea cabling business. So right now we have cables built through Africa 1 and through back to Europe, where we can get 60 milliseconds or less round trip, which is decent enough for a lot of low latency work like inferencing.
Or if you heard Jensen's optics vision, maybe there's something more exciting in 5
Oh,
years
yes.
that.
Yes.
Okay. All right. I know we're at
Hello?
time. Oh,
Yeah,
yeah,
we're
sure,
good.
sure. Okay. If you're fine, that's fine.
Please.
Okay.
Yeah.
Oh, hello. Thank you so much for lunch, and thank you so much for speaking with us. And you really gave us a lot to think about. Last year, Jensen said that Hopper was the innovation. And in his keynote, he said that Blackwell has 40x the capabilities of Hopper. I would love your feedback on that. Thank you.
Go for it.
no, that's server side, man. That's you.
Oh,
So-
here's me like, no, I'll talk about that because that's really external.
So it's incredible the amount of innovation that's happening in the GPU space, right? Like in terms of the scale that is needed. When we think about where is Hopper versus where is GB, right? Like so, as we go more and more towards multimodal, and we want to improve the accuracy, we are going to see $1 trillion parameter models coming through here pretty soon, right? Like so, what that brings about is a conversational interface for all of us to talk and experience the whole world of AI in our fingertips. And the second thing is, again, he talked a lot about inferencing. This whole notion of agentic AI is going to bring in so much more data and so much more instant inferencing that you need across all of this data that you need an architecture like GB300, right? Like for us to enable all of this in a low latency manner. So what we are thinking about is this, right? Like, so in terms of training and real-time training and context-sensitive training and fine-tuning, these GB chips are going to be really helpful. And we're going to use Hopper and the H100s and the H200s more for mass scale plain inferencing, which is still needed, right? Like I'm still going to ask a question, what is science? How do I renew my driver's license? These are very simple questions that can be answered through low power and low latency architectures, and that's what. So there is use for everything. We have to be very use case centric, and we are defining those use cases, and we'll put these to play for the right use cases.
I think the issue there is around reasoning models versus just kind of query.
Yes.
I mean, that's how we kind of keep it straight. I think the thing I'd say about Hopper is if you think you've got data movement challenges now, when that thing starts getting deployed out there, it's going to be even hungrier.
Yeah.
And so you really need to, I think the part of the whole play here around data that customers are going to have to struggle with for a while is how do you take this data that's the most valuable thing we have, that's feeding all of what we're talking about here, and we've got to get it off of legacy infrastructure. It can't be sitting behind a 10 gigabit Ethernet and mean anything to a Hopper-based processor, right? So if you look at the 30 years of infrastructure that you all have deployed, it at some point has to get upgraded and moved and remanaged in order to feed these machines. And that's the massive piece of work that I don't think we all talk about enough.
No, we don't.
Is how do you modernize the legacy? How do you say, okay, do I want that up on the cloud? Do I need to move that on-prem now? Because it's just not available. And when I look at our work with enterprises, this is the long pole in the tent, to be honest. We have a project we worked on with a bank, and it's a brilliant project. The problem is all the source data is in Glacier. And the project will take them 3 years to take it out of Glacier.
Out of Glacier.
Wow.
Okay, so you can think about it. I love all the advances in NVIDIA pushing it, but I also get very practical about where can the data intercept that intelligence, and we have a lot of work to do.
Yeah, just adding a little bit of memory on the. No.
Yeah, a little bit of memory is not going to help.
That's not going to help. Are there any more questions? Yeah. Oh.
Yeah, sir, one more question. Great discussion, and thank you for sharing your thoughts. Are you also building in Scandinavia where power is really cheap? And what's your approach to that region?
In Core42, yeah. So we have data centers right now under contract in Grenoble for Europe, and we are talking to providers in Finland. Is Finland Scandinavia? I don't know. I think it's kind of the border, but it's close enough, I guess.
That's a Finn.
So Finland's great because it's got a lot of green energy, and cooling is not a problem because you just open the door and it cools itself. So it's very cost effective for us, and we are looking at Finland as a potential location for us.
And they can loop all of the hot water through their buildings. It's genius. And they can heat all of Finland with the data centers. I love that. All right, anybody else? Okay. Any final thoughts, guys? Is there anything you want to leave people with here before they go back out into the wild GTC world?
So I did remind folks, if you take one thought behind, it's unified architecture. There are only 3 components here, right? Like when you build an AI cloud. One is the GPUs and the compute. The second is network, and the third is storage. If you screw this up, I was telling them, if you screw these 3 components up, you'll never recover as a provider, right? So we are very focused on how do we unify these 3 layers, and a unified storage in that sense is a very important component, and we are really focused on that one.
Yeah, the thing I'd end with is we're doing really, really complicated things as an industry right now. And the only ones that I see that are actually moving to completion in order to be able to provide the value they're dreaming of are the ones where there's really good partnering. There's no one company, not NVIDIA, not VAST, not Core42 that can do this by themselves.
Correct.
And to find, kind of your team of companies and people to be able to, who are all kind of sharing a vision and are willing to work to make that vision happen. I think we're at that stage of this industry growth. This is not plug and play, folks. If you're here in this room, you know that this is a lot of work. And it takes a lot of innovation and it takes a lot of partnering. And I think we really value our partnership with Core42 and the team there because they're pushing the envelope. We love their worldwide vision for what they're trying to do. And we love having design partners. This is what drives VAST forward, is not our own engineering teams contemplating the future themselves. It's working in the real world with teams like Raghu's to really come out with the solutions that are applicable to people's lives. And yeah, so finding your partner ecosystem, find the people that you can team with in order to get these things done.
And that's just how VAST started too. It started by listening to what do you
Absolutely.
need? What's not working?
You got to listen. Yeah.
Right. Okay. Any more questions? You good?
Thanks.
All right.
Thanks
Hey,
for coming.
thanks everybody. Thanks guys.
Thank you very much.
Yeah.
Thank you.